Okay, so what we're going to talk about today is something called domain and range. So this might be a little familiar sounding, and we have seen it before. So first of all, we're going to talk about the definitions, the formal, and kind of what that means. So domain is what can go into a function. Now, what that means, we're talking about the inputs of a function, and we also know what that is as the x values. So what can go into a function, x values, we call that domain. It's all the options that can go into a function. The range is what comes out of a function. And so the output, we know that as the y values. Now, what we're going to talk about today is how do we list off or explain what the different domain and ranges of a function are, given different graphs, tables, mapping diagrams, and the sort. So first thing is we're going to have to talk about what it looks like for a discrete relation. So thinking back to what we've already learned, a discrete graph is something that is not connected, or in other words, it's just a bunch of dots on a graph. Now that's also going to be the same as coordinates, a table, and a mapping diagram. All of these representations are seen as discrete. So anytime we have a dotted graph, a table, coordinates, or mapping diagram, we will write the domain and range like this. So what we're going to do is make it as a list of numbers using these types of brackets to surround them. Now these are technically called braces. They're just kind of like little squiggles. Now, what we're going to do is write our domain and range from least to greatest. And we never repeat any of the numbers in our list. So let's say there are a couple threes maybe for our y values, we would still only write the number 3 once. So never repeat. Lists are just listing off everything you have. So what we're going to do is put our coordinates into the different forms, and then we're going to pull domain and range. So go ahead and graphing. We're going to take 2, 1, so that's x is 2, y is positive 1, 0, 4, 3, 2, negative 1, 4, negative 2, 0, and then 1, negative 3. We're going to write this into a table. Now, what is nice about putting it in a graph is actually now ordered. All of these coordinates were all over the place, but now that it's on a graph, we can kind of read it from left to right or least to greatest. So the leftmost point is negative 2, 0. So I'm going to write that first. My next point is negative 1, 4. Next point is 0, 4. Then 1, negative 3, 2, 1. 3, 2. So we put this into a graph, the graph organized it, and then we wrote it from least to greatest in our table. Now, what we're going to do for our mapping diagram, one thing we have to be careful about is a mapping diagram also never repeats any values. So even though we see some of our outputs are the same, we're not going to repeat that when we list off our y. So I'm going to go ahead and list all my x's, negative 2, negative 1, 0, 1, 2, and 3. Then we have 0, 4. Now again, 4 is written twice, but we're not going to write it twice. Negative 3, 1, and 2. And then I draw an arrow for what everything goes to. So negative 2, 0, negative 1, 4, 0, 4, 0, 4, 1, negative 3, 2, 1, 3, 2. So mapping diagram showing all our values. Okay. Now, domain, remember this is the list of our x values. So we could read it from a couple different places. So sometimes the easiest to read it from would be the table or mapping diagram because it's already kind of listed out for you. So what we want to make sure is we are going from least to greatest and don't repeat. So we already have that in order here. So I'm just going to write off my list, negative 2, negative 1, 0, 1, 2, and 3. Now, what you may notice about the range, though, is that it is not in order. So you'll have to kind of sort through this. So the lowest value is negative 3. The next value is 0, 1, 2, And then we have 2 4s, but we only write it once because we're just listing off the values. So there's only 1 4. Now, last question, is it a function? We can see from a couple different ways. Vertical line test, it passes. My x's don't repeat, so yes, it is a function. So now we're going to put this function, so remember this is a function based on the variable x, into a table. So we're just going to input the x values to get our y. So input -2, so 2 times -2 is -4, minus 1 is -5. Input -1, so 2 times -1 is -2, we get -3. And I'm just going to go ahead and put this in quickly for you guys. We get -1, 1, 3, and 5. Okay. So let's go ahead and graph these. So we have -2, -5, -1, -3, 0, -1, 1, 1, 2, 3, 3, 5. Now, we're not going to connect this because it doesn't say to, so we are going to leave this dotted. We don't know if the individual pieces between it are connected, so we just leave it as a dotted graph or discrete. Now we're going to list off our mapping diagram. So for this, I like to kind of go back to the table because it mirrors it pretty well. So -2, -1, 0, 1, 2, 3. My y value is -5, -3, -1, 1, 3, and 5. And nothing repeated, so I didn't have to worry about that. So now I draw my arrows. -2 goes to -5, -1 to -3, 0 to -1, 1 to 1, 2 to 3, 3 to 5. Now, what I'm going to do is read the domain and range from the graph in order to write this. So when we're writing domain, remember we want to go least to greatest, and that's the x-axis, what we're talking about. So the least is going to be on the left side. The greatest is going to be on the right. So the least x, or the lowest x value used, is -2. Then we have -1, 0, 1, 2, and 3. Now, range is the y values, and that would be from bottom to top, right? The lowest y values are at the bottom, the highest ones are at the top. So the lowest would be down here at -5, then at -3, -1, 1, 3, and 5. Is this a function? Yes, because nothing repeats. All right, so now kind of isolating these. So on this first one, we have a mapping diagram. Now, if you look at the input, it's listed as input, but that's also domain. Remember, it's part of the definition. So writing the domain, this one isn't in order, so you need to pay attention to that. So domain, remember, is least to greatest. So the lowest is -10, 1, 3, and then 6. For the range, that's the output, so the y values, the lowest one is 11, 13, and then 14. So nothing repeated, so we are fine, just listing least to greatest. Is this a function? The answer is yes, because there's only one arrow coming from each domain. All right, so domain from coordinates. So domain is the x value, so I'm just going to go ahead and underline all of them to isolate them. So they're not in order, so I do need to rearrange that. The first, or the lowest, is -1, 2, then 5, then 8. Now the range, I'm going to use little squigglies to kind of separate those visually. And looking at those, I have, let's see, -1, 4s, and 2s. So -1 will go first, then the 2. And now what you'll notice is there are 2 4s again, but I don't repeat in my list, so I just leave it as 1 4 because I'm just listing off what's being used. Is this a function? Yes, because the x's did not repeat. All right, and we just keep going. So domain, lowest value, that -2, 1, 2, and 3. Range is the y values. Now you'll notice there's a 3 and there's a set of 4s. We only write 1 per number. So 3 and 4 is the range. Yes, it is a function because the x's did not repeat. All right, so we are going to save these for class. Okay, so make sure you leave those blank, save those for class. Now what we're going to look at is something called continuous graph. So remember, continuous means connected, so there's no breaks in our graph. Now, how we're going to write our continuous graphs is as an interval, or sorry, as an inequality, and this is going to go back to greater than, less than type concepts. Now, we mentioned this with the graph before. Domain, you read from left to right, and that's just along the x-axis. For range, you're going to read from the bottom, right, lowest, to the top, and that's along the y-axis. Now, you're always going to use a less than symbol, but it depends on whether you're going to have an equal to or not. That's the only thing we're going to have to figure out. You're going to use an equal to when the graph is going through or includes the value. You're going to just use a less than when the graph is not including the value. So I'll show you exactly what I mean in a couple examples. Okay. So first one right here, domain, remember that's x-axis, which is this one right here. So what we're going to do is we are going to read where this graph starts and ends. So the leftmost point on this graph is right here, and I'm going to take that up to the x-axis. Where it ends, so we see it travels all the way along, we're graphing all the way until here, which stops at this value. So my graph begins at -4 and it ends at 3 on the x-axis. Now we're going to write this as an inequality. So what you want to look at is open or close. Am I including the dot? So on this one, it's an open dot, which means it's not included. So we're just going to use the less than symbol. We're going to put x in the middle to say x runs in between these two values because it's being graphed all through here. And then if I look at the 3, it is a closed dot. It's shaded in. So we're going to use less than or equal to say included. So what this says right here, my x values are between -4 and 3, but I'm not including the number 4 or -4. So the same idea for our range. So our range at the bottom, right, the lowest value is here, at the top is here. So at the bottom, we're starting at -2, and it's not being included because that open dot. And we're going to say our y's run between this -2 all the way up to the number 5, and 5 is included because of that closed dot, so we use an equal to. Last question, is it a function? The answer is yes, right, because it passes that vertical line test. So we're just going to keep practicing that over and over. So next one, this first example here, our x values, right, x-axis is here. So I'm going to bring this down. X starts here and ends here for our graph. And so my x is running all along that part. So where does it start? It starts at this number, -5. Now it's not included because of this open dot, so less than x, and that is less than 4. And again, that is not equal to because of the open dot. Now, y is the same concept, bottom to top. So the bottom of this graph is here at 4. The top is at 5. So we have a very small range that it's running through. So the lowest is 4 to 5, and both of these are still open dots, so there's no equal to, it's not included. Is this a function? Yes, it passes the vertical line test. Okay, next one, we'll just keep going. So domain, we're going to take it to the x-axis. So the leftmost, remember we read left to right, so leftmost is here, rightmost is here. So x is graphed all the way between here, so this is my interval, my little inequality here. So -2 is the beginning, and that is less than or equal to x, which is less than 2. So remember, this is a closed dot, so equal to, open dot, not equal to. Now, the range is going to be a little tricky for this one. So first off, we start it the same way. The lowest it goes to is 4. highest it goes to is up here at 0, and it's all between here. Now, what you'll notice is there are two dots for this specific point, an open and a closed. Because there is a closed at -4, even though there's this open part, we're still including 4 at some point. So this is going to be considered included. -4 is less than or equal to y because of that closed dot. Now, up here at 0, we don't have a dot. But what you can see is that our graph is running through 0, which is part of the definition, when the graph is going through the value. So because we're going through 0, we are also including 0 as part of our graph. So my y runs from -4 up to 0. Is it a function? Yes, because it passes the vertical line test. All right, next one. I want you guys to try this one on your own. So go ahead and pause the video, give it a shot, do your best, try what you can, and then see how you did. Okay, so framing our graph, x's, right, bring those down, okay. So domain starts at -4, and that's included, x, and it goes all the way up to, and it kind of looks like 2.5 here. If you put a decimal or rounded it to 3, that's okay. They'll all be very clear on what we're using. So I'm just going to round up to 3 here because it's very close to that 3. It just, the graph was a little off. So included on both sides, -4 to 3. Our range, the lowest it's going to, the highest our graph is going to. So -2 less than or equal to y, less than or equal to 3, equal to's because on both ends are closed dots, and we do pass the vertical line test, so it is a function. Now, this last one that we're going to do is the unique one, and this is because of the endings. What do we see at the end of these? Arrows. So we're going to kind of talk about what that means. Arrows mean they go on for forever. So if you were to frame the box as is, you would think, okay, it's at 2 and it's maybe at -2. But the arrow says it's going to keep going at this angle for forever. So where is forever? Well, on the left side, that is -infinity. On the right side, that is +infinity. So my domain is going to go from -infinity to +infinity. The range is going to have the same concept. Even though it looks like it ends at -5, ends at +5, what do we have at the ends? It's not open and closed dots like we had before to evaluate. They're arrows. And those arrows mean we go on for forever. So the lowest forever is -infinity. The highest forever is +infinity. Now, what you'll notice is there is no equal to in these because we cannot reach infinity, so it's just a concept, so it's always going to be not included. Is this a function? Yes. So we will save these last two for class. Okay, so that is it.